They got a charging port? Oh, some kind of. Oh. I see. If that's the case, we'll wait on that. Is it? Yeah. Charging, we'll wait on it.
Good morning, everyone.
Good morning.
Oh no, y'all gotta start sounding chipper.
Okay. Increase a little bit. Yeah. I guess I have to call you back for it. Somebody will help. Okay. 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 Who's making all this noise? Good morning.
Good morning.
Good morning, sir.
How are you?
Doing great.
Okay.
You with food in my mouth.
Participant. We have. Let's see who's on the call. Let me put my microphone here first. So you guys okay now or what?
You sound good to me.
Okay. Let's see. Ready, check that. Okay, so we would start with talking about wireless yesterday. So I think we had a wireless component. So you have a video so you can watch it. Of course, what you see in wireless at your home, for example, is different from a commercial wireless. Because at home you have what we call a wireless router, which is a component has a multifunction. Like it's a router, switch, access point, DHCP server, DNS server, and all that stuff. But usually, when you implement wireless, you have the wireless, for example, access point. You have the wireless. With the access point, you have antenna, and sometimes you can see the antennas. It's outside. Sometimes you don't see it because it's inside the antenna. And you will have what we call autonomous and controller-based access point. This is a different types of access point. I will talk about this one in a few slides down. Okay, so then you need the wireless NIC. This is the receiver, basically. The access point is like a radio. The radio is gonna send what we call beacons, like a signal, to announce its presence in the area. Now, the radio, is going to send that signal. The receiver is going to receive that signal. Now, once you receive it, it's going to associate with the access point if he has the credential, because you need to log in. And if it's secure wireless, you need some kind of a key, shared key or username and password. Depends on the setup. Yeah, that's basically what you have at your home. Similar to this, you will have a wireless router, you have access point, you have the router, you have switch, because you can plug like 4 devices to it. So that makes it a switch. And of course, you have a WAN connections, this basically, and you can go to the internet. So this is what we call home router. This is like a home router. Any question at this point? Are you guys okay?
No, sir. Yes, sir.
I'm good here.
Okay. So we have a different types of AP categories. When you say AP means what? Access point. So we have the autonomous AP and the controller-based AP. Autonomous means what? Means the access point store or the username and password to log in for the user to log in. Usually you don't need username. Usually you'll have what we call a pre-shared key. You enter the key or basically the password to access the wireless. And that's what you call autonomous. Autonomous means what? It has everything's built in. It does not need a controller or a server. And usually for commercial, we don't have this one anymore. Okay, it still exists, but for commercial, like hospitals, colleges, and stuff like this, nobody wants to design autonomous APs. Why? Because it's a lot of overhead. Like you have to take every AP in there and go individually configure it with shared key, which is not secure, blah, blah, blah. There's a lot of hassles. But if for home use, that's okay. You can use this kind of autonomous AP. So the autonomous AP is basically the user or the devices that can associate to it by what we call shared key. You can put a key in there. Or we have the controller based, also known as lightweight access point. That's what you see in ceilings and all that stuff all over the places. And these are controlled, or I don't want to say controlled, are managed by what we call a wireless access controller. Like, for example, we used to have one wireless controller on Arduino building manages all the access points from Vilplat all the way to Franklin, so in one controller. So basically, when you have the controller, you don't have to go, you just plug it in, plug the access point in, and the rest of it was done by the controller. So that's like if you have an enterprise environment, that's what you use. Now, of course, this one, it's we used to use like you can use a physical box with the controller or appliance, like which is software. But now what they do, most of the manufacturers like Meraki's and what do you call it, Lynxes, all those new branding, Ubiquiti, they have something called web wireless controller. Now, basically, everything you need to do is through the web. So you can manage thousands of APs all over the places, all over the states on the web. So it makes it a lot easier. Plus, you can see the status on graphical interface on the web. So it really makes it easy. And I have a lot, I mean, it's a lot of things to learn about it. And the most important thing with the wireless is how to be able to manage it, okay? Because the wireless has different, they use different technology or different access methods, I should say. Um, so you need to know, for example, how many users they can access the AP, because the wireless operates at the physical layer and the data link layer. So you need to make sure you configure it properly. And usually you take a class, like some people are specialized in wireless. They take like a couple of classes, how to manage APs, how to configure them, how to secure them, to eliminate interference. So it's, all this is done. Now, they have special software. It makes it easier for you to configure also, to manage all the APs. Let's see what it is. So, in this slide, you need to know that you understand the two things. That what's the difference between autonomous APs and control-based APs. APs stand for what? Access point, okay? Which is, this is the radio. Some people call it the radio. There's a radio sends signals, announce its presence, and that signals will be communicating with the receiver. Receiver basically is on your device, like a tablet, laptops, or whatever. And your device is supposed to have some kind of wireless network card built in it. Okay. Some people say, well, I don't have wireless network cards, so now they can buy a USB wireless card you can stick into your laptop or your machine to make it wireless. Now, when it comes to commercial, you need to worry about the wireless antenna. And we have a lot of different types of wireless antenna. Each type makes a big difference on how you handle signals. Because basically, the wireless is not going through the wire, okay? It's going through the atmosphere, through the air. So how you direct that signal, it depends on the what? On the antenna. So we have some antenna called omnidirectional antenna, which provide 360-degree coverage, ideal in house and office area. So basically, when you have an omni antenna, the signal goes into, or you can catch the signal from different places, from a 360-degree angle, which is good. Now we have a directional, which is focused the radio signal in a specific direction. And the example are the Yagi and a parabolic dish, like this, which is a specific direction. And this is good, like, for example, I don't know if you're familiar with, TH Adams has the main campus and branch campus. So one time we said, okay, we need to use wireless. So we point this antenna toward the branch campus. We put another antenna on the other building. Basically, you point it to the specific direction. Okay? So that depends on the environment, what you're trying to accomplish. And of course, we have the multiple input, multiple output, which is DEMO, use multiple antenna, up to 8 to increase bandwidth. Yeah, because really, the radio or the AP basically by itself is going to generate the signal, but what extent that what happened is you have a small wire on the AP. That small wire basically is connected somehow to the antenna. The antenna is what we call a decibel, like it gains signal. So it depends on the type of antenna. So if you have a good antenna, you will have a good reception. If you don't have a good antenna, you're going to have bad reception. And, well, we'll talk about the signal because it depends on the environment. Basically, if you have an open air, no obstacle, no objects in between the sender and the receiver, you're going to have a good signal. But if you have some kind of like concrete wall or wood, or it depends what objects you have between you and between the access point and the receiver. Of course, the signal is going to bounce, it's going to radiate, it's going to change directions. So you're not going to have a perfect signal in there. So they cannot talk there. So antenna makes a difference, and you need to be familiar with the types of antenna. What I mean by omnidirectional, directional, and multi-input, multi-output. Multiple input, multiple output. So it depends on the types of antenna. Okay, so we talk about wireless WAN. Let's see. So they have some kind of video, you can watch the video, but we have different types of wireless technologies. For example, same thing we have in regular computers, we have, whenever you want to do a network, you can do like connect two PCs together with wire and they can communicate so you can share files. Now, can you do that with laptops with wireless? Have it wireless? And the answer is yes. We call that ad hoc mode. The ad hoc mode basically is you establish wireless connections between two end devices without having an access point. And that's what we call ad hoc. And that's the picture of it right here. And in the other one, we have the infrastructure mode, which is basically you will have a bunch of devices, but in order for these devices to communicate wirelessly, you need an AP, you need an access point. And that's what we talk about the infrastructure mode. So, any question about ad hoc and infrastructure? So, this is like a few questions on the test. I bet you this is a good question. I'm going to ask you that. Let's see.
Mr. Charif,
Yes, sir.
would it would a Bluetooth connection or an NFC connection be considered an ad hoc mode?
I guess so, because we're talking about wireless LAN. Wireless LAN is different from WPAN, wireless personal area network, which is Bluetooth and stuff. But to answer the question, yes, it's the same thing because you're communicating with end devices without having an AP. Yes. And this is we use here. Okay. We talk about a wireless LAN. You see that wireless LAN operations. The other one is a wireless PAN, personal area network with Bluetooth and stuff like that. But yes, because the devices communicating with each other, like for example, if you have a keyboard or wireless keyboard, and you want to connect it to your wireless machine, you can. With the Bluetooth, yeah. But that's a good question. But think about it this way: in order to communicate with your wireless keyboard, what do you need? It's not the
An
same.
adapter?
You need the receiver because you have the wireless access point. I mean, the wireless keyboard. Then you have the little dongle that you put in the USB. So without that little dongle, you cannot access the keyboard. Your computer cannot use that wireless keyboard, right?
Correct.
Yeah, so it's a little bit different because over here it's like from one neck to the other. So you need that wireless network card in both sides. So I think in the wireless LAN, and I think it operates different from WPAN. Okay? Because you need that little dongle. Without the dongle, it doesn't work. Now I have at my desk Logitech. I bought a new mouse and the keyboard, and I lost the dongle, so I cannot use those. And unfortunately, they don't sell just the dongle. So I paid like
Right.
$50 for that one. But I lost that little stuff that you put in the USB, so I cannot use it. So you need that little piece to communicate between your wireless keyboard or wireless whatever controllers. But now we're talking about the wireless LAN. Wireless LAN, if you can do like two laptops together, and this is what we call ad hoc. Now the infrastructure, like we said, you need an access point. Now when we have tethering, which is basically, I'm sure you're familiar with that. This is when you make your, for example, your phone what as an access point or as a router, actually, a wireless router to go to the internet. Okay, and this is what we call tethering. It's variation of the ad hoc topology is when a smartphone or tablet with cellular data access is able to create a personal hotspot. And some of you all, I'm sure, using that one, especially if you are in a small town with no kind of internet. So people use the cellular signal to go to the internet. So that's what they do. So basically, your laptop is going to go to the internet by connecting it to your phone. I mean, this is good. It has a lot of advantage and disadvantage. The advantage, if you need it, you can do that. But you need to be careful because you're going to consume a lot of data time, whatever you call it. You have unlimited data, it's okay, but you have limited data, you're going to be charged. So be careful. Okay. Now, we have something called wireless operation. We have the basic service set, BSS, and we have the extended service set. Basically, you have one access point, and that's what we say basic. Use a single AP to interconnect all associated wireless clients. The clients in the different BBS cannot communicate. So what does that mean? In here on the picture, you have a basic set right here and basic sets here. This group is connecting to this access point, and this group is connected to this access point. Now, those two cannot work together. They cannot communicate. And the reason why, they have a different SSID, they call it SSID. So in order to communicate with wireless devices, you have to be on the same SSID. It's the same thing, like we have what do you call it, to be on the same router to connect to the interfaces. So that's a similar thing. Now, can you extend your wireless area or your service area? And yes, it's yes. So you can put, for example, on the switch, you can put multiple SSID. And actually, that's what they do. Like when they design enterprise area, they extend it in such a way they put it like your overlap, your signals overlap, so that will be to eliminate what we call dead dead spot. Let me see if I can. Whenever you design it, you have to do it in such a way. Oh, no, it's okay. So this is your access point right here. It covers all this area over here. Then the next one, you put something like this. Okay, and cover all this area, and the next one is gonna be like this. Follow? So the signal is supposed to be overlapped. So if you use it, for example, wireless voice over IP phone or something, and go over here, okay, and you walk in. As you walk, you're gonna have continuous signal because you're coming from. Well, you begin in now with this access point, then you move it in. Now you get in between the two, and your phone, the signal is going to change to whatever access point has that strongest signal. And as you walk out, you still can't communicate. So if you design it like this, okay, that's not good because as you walk this way, you have that spot right here. Yeah, that will be a dead spot. And you have that spot here. And you have that spot here. Now that's not a good design. So that's why they designed it in such a way like this, that they have continuity. Continuity in coverage. Okay, so you eliminate what we call dead spots. Does that make sense? No, it does not.
Yes, sir.
Okay. One person said it makes sense. That's good. So how about the rest of y'all? Do you agree with them or not? I see. Where's the chat? Chat. Nobody chat. Okay, so and this PowerPoint right here, it's really this chapter is about reading material, but it's good to know the difference between BSS, basic service set, service set, and extended service set. This talks about frame because we just mentioned that the wireless basically is connected to a switch, and that's why you call it wireless LAN. It's LAN. So basically, we operating at the physical layer and a data link layer. Why physical layer? Because we deal with antennas, and the antenna has a strength of the signal. They measure it by dB, which is decibel. And they have a lot of different formulas how you calculate that, but this is beyond this class. To calculate the gain and loss. Okay, so, but at the end of the day, it's a frame. Okay, which is basically, it's the same thing as any frame, but it's slightly different. Okay, because we use the IEEE standard 82.11 frame. But this one has a little bit more fields. Okay? So they have a few more fields in that, but it's the same structure. I don't know if you guys have a modem. You remember the modem? A long time ago, you used to have a modem. And I was wondering, in the modem, they have some kind of LEDs, and in LEDs, they have RTS, CTS, all that stuff. I was wondering what those for. So that's basically on the wireless, they use, because like we talked about before about Ethernet, which the Ethernet, they share the media, like I said. So how they need to access the media, so they use what we call the collision And they have the carrier sense multiple access, which is CSMA slash AD, collision detection, CD, collision detection on the internet. Now notice on here we have something called use carrier sense multiple access with collision avoidance. So who else has collision avoidance? Remember when we talked about this a long time ago? Collision avoidance. That means we have to wait before we send the signal. So we need to detect anybody using the signal, so we have to wait. And that's pretty much like what? Like half duplex. It's like in half duplex. We have to listen to the channel to see if it's idle. If it's idle, then we send the traffic. If it's not idle, we have to wait. And that's why you have something called sends, a ready to send RTS message, the AP request access the network. So that's what the RTS stands for. Ready to send. And you have a CTS, which is the clear to send. Okay, so when it comes to wireless, it's a science like itself, a lot of physics, because we're not dealing with the digital signal. This is the analog. It's like a wave. Okay. So that, like, think about this one. If you go to a pool and let's say you throw a little rock in that pool, what do you see? You see like a circle, like in a wave, and the wave starts moving to infinity. So that's basically how they operate. Transmit the data and send acknowledges all transmission. If a wireless client does not receive an acknowledgement, it assumes a collision occurred and restart the process. So this is basically the steps how wireless client communicate. They use the 1, 2, 3, 2, 6, okay, to make sure they cannot send at the same time. Either you talk or you don't talk. So it's almost like have to. I think with the new technology now, they improve it a lot, and you can do almost like overflash. And that's what they call it multiple input, multiple output, and multiple users. Okay? So that's a new technology they have. Okay, so what happened? You have, for example, wireless client right here, and this is your AP, which is the access point. And that's what it says. For wireless device to communicate over the network, they must first associate with an AP or wireless router. So basically what's happening, when you have an access point first, this guy is going to send what we call a beacon or a signal. Okay? Let's see, we still have a little pencil. Yeah. Oh, this guy sent a signal. This beacon, we call it. I should send it like this. So, in the form of wave, you know what I'm saying? That's how it's and it basically announced its presence. I'm here, I'm here. So when this guy has a little antenna, a little wireless network card, when you open it, for example, like in my case here, you go to let's see, you go to your network here. I don't have wireless, but you go to wireless here, and you click on your wireless Ethernet. It's going to tell you who you want to, the SSID of this guy is going to broadcast this SSID if it's configured that way. Okay, because for security purposes, sometimes you don't broadcast your SSID. So you're going to see a name, for example. You're going to say classroom 601G, whatever the name of the SSID. Then you click on it on your over here, and it's going to prompt you to what? To put your code. You have the code, then you associate with the access point. And anybody else associated with this access point, they can talk to each other. For example, if I have another laptop over here, and associate with the same thing with this one here, those two can communicate because they are on the same SSID. SSID in this regard is similar to having two computers on the same work group. Okay? Because in PCs, if you have two machines wants to talk to each other, they need to be on the same work group. By default, Windows has work group, but you can change. Say, change my work group to RM, change it to 601G, classroom, whatever. But as long as you are on the same work group, you can talk. And the same thing in here. As long as you are on the same SSID, you can talk. And that's what they're talking about here. Wireless device complete the following three-stage process. Discover the wireless. This guy is going to send signals, and you need to authenticate the AP. Authentication here, it takes a different form. You can authenticate, basically put in the shared key, which is the AP. I'm going to see it now a little bit. I can give an example about that. And after you put your key and you approve it, now you are associated with AP, then you can communicate. You want to go to the internet, you can access a file server somewhere, whatever on the network, that's fine. If you want to print, whatever. Now you associate with the AP. And this is a very important step. Discover a wireless AP, authenticate with the AP, and associate after you authenticate. Those things has to be on sequence. Now, sometimes I think they explain it in the second slide or so. I'll wait for that. So sometimes what you do, like for example, if you have an AP, you want to make it secure, you want to share it among like few friends and stuff. You say, look, I have an access point where the SSID is hidden. So this is, if you go to your network, type this SSID name, and you can connect with it. So sometimes you will have access point, but it's not announcing it's present. And this is like a security purposes. You can do that too. And that's what we're talking about, wireless client and AP association. To achieve successful association of wireless client and AP must agree on specific parameters. Number one, you need SSID. The client needs to know the name of the network to connect. Now, how the client's going to know the name of the SSID? You get two ways, right? One, you can point to what? To broadcast.
Broadcast it.
Yeah, broadcast the SSID. Or you can hide it and you tell the client, look, tell your friend or whoever, say, look, I have a access point and it's not announce it is present, but this is the name of it. You can use it, and this is the key, the password, basically. And that's how it works. So you will connect to the SSID. You put your password. This is required for a client to authenticate to the AP. Now, in some cases, like when you go to CCs, like coffee shops and stuff, and sometimes you have open access point. Basically, it does not require to put password. So you'll select it and you will connect to it. But if you have a secure wireless, you need to put some kind of, you need to authenticate. And you have the network mode, which is 82.11 standard in use. And you have security mode, which is security parameter setting, like with the WEP, WPA, or WPA2. So WEP is not secure at all. So if you have Wireshark and you sit in the middle, you can really see the password, okay, or the key. WPA is a little. WPA2 is better, and WPA2 Enterprise is even better. Okay. And they have the channel setting, with the frequency bands. Basically, you'll have 82.11, AC or AX, whatever. And that's basically wireless client and AP association. Okay, so passive and active discover mode. Passive mode, basically, and AP openly advertise its service by periodically sending broadcast beacon frame. That's what I'm talking about. So basically, the AP sends signal to announce its presence. Okay, that's basically what that means. Now we have the active mode, which is wireless client must know the name of the SSID. So this is basically, it's not, the AP is not set. It's not set to broadcast the SSID. So the client need to discover it. Well, the client's not going to discover it unless I go ahead and this is the SSID and this is the key. Go ahead and log it. Okay. So question I have. Okay. Well, the network overlap. All the access point would have to share the same SSID because of the anyway. Yeah, you can. Yeah, all of them has to be set on the SSID, same SSID. All right. Let's get. Yeah, same thing. Like for example, we'll talk about that in a second about the association. But this is very important, and it depends on how you configure the AP. Okay. This is another. This talks about the CAP WAP, which is control and provisioning of wireless access points. Okay. Split media access control, MAC architecture, and talks about the encryption. So basically what that means is, okay, so whenever you design wireless in an enterprise environment, suppose you work in a hospital or college or any of these, or you well, any of these places, you're not gonna manage one AP by itself, okay? You go and manage every single AP by itself. So the APs is gonna be part of the controller. That's why the wireless controller basically take care of all the management. You put, like, for example, a template here, and you push it to all of that stuff. But you don't need to fool with this, okay, with the AP. All what you need to do with the APs, okay, you plug it into a switch, and basically, hopefully you will have what we call power over Ethernet port, and you connect that APs to it, and you put the wireless controller, and the wireless controller doesn't have to be on the same, what do you call it, network. It can be on a different network. Like I said, we have an Oregon building. We used to have WLC, which is a wireless controller, manages all the IPs from Bill Cloud all the way to Franklin. So you don't have to be on the same subnet to do that. But this guy will manage all the IPs. And now it's even better. We don't have to put a physical box or physical wireless controllers. We can do it through the web. All the access points that you see in our building, SLCC now, is managed on the web, because last summer, I think, they changed the APs. They put the new, I think, Meraki's access point, and all controlled by the web. You can manage it by the web. So that's basically all about this. I don't have to put anything in here except connect it to the web. Ethernet wire and mount it on the ceiling, and that's it. And the rest of the management is done remotely through the controller. Now, of course, they talk about the WAP, was it IEEE standard protocol that enabled a WLC to manage multiple APs and wireless LAN. Okay, so based on lightweight, that's what we call lightweight APs, would add additional security with datagram, transport layer security. So yes, everything is secure through the controllers. This guy has no security. Why? Because in the old days, what we let's see, what is that? In the old days, this is how we used to do it, which is not not good. So you have an access point right here, right? That's how we used to do it. That's a bad access point. SSR point is bad. And that's your access point. Okay. And that's you over here. I don't know. That's good like this. So if you want to connect to this one here, so basically the key, locate the key, you need to locate to this one here. Okay. But now you don't have to do that anymore. So because this is going to take overheads. It's a lot of overhead on the access point. So now what you need to do is you want to access this guy here. Okay, everything is in here. Through the controller, and the controller would have to okay. Or it's sometimes they will have remember we talked about the AAA server. So sometimes you go to the AAA server too. So you will ease the overhead on the access point. So the access point only have one duty, is to give you a wireless signal. That's it. They don't authenticate you, they don't do that. Anyway, so you need to be familiar with the encapsulating the forward the wireless client, traffic between AP and WLS over tunnel using 246 and 5247. Why do we need to know about these ports? Let's see, who's the smart guy going to tell me why do I need to know about these ports? It's Wayne.
For port forwarding issues.
Yeah, like for example, because like I mentioned, the wireless control is going to be in a different network. So if you have some kind of firewalls in between these networks, you need to make sure you open those ports. The 5246 and the 5247. Or connected. So operates over both IPv6 and IPv4. Use IP protocol 17. IPv6 use IP protocol 1.6. That's a lot of stuff to learn about wireless. Like this is like one chapter or so, but really, you take courses on the theory of wireless. You need to know a lot of physics. Specialize in this. It's fun though. I like it. Actually, we used to have a class called CCNA Wireless. I don't know why they did it. Too many classes. Too many classes to teach. Okay, what we have here is split back architecture. So the flat split back concept does all the functions normally performed by AP MAC functions and wireless ones. Let's see what's the AP MAC functions, beacons and probe responses, packet acknowledgement and transmission with queuing, packet prioritization, MAC layer data encryption. Over here you have authentication, association, reassociation, roaming clients. What's roaming? Roaming basically allow you to go between different SSID, okay, or different AP. Print translation to other protocol and termination of 802.11 traffic on and wire. So most of the implementation that we do in modern day now, we don't use AP is not responsible about anything, just provide wireless. All the other overheads they handle by. Put it that way. Let's see. Yeah. Flex Connect AP, Flex Connect enable the configuration control of APs over WAN link. There are two modes of options for the Flex Connect AP Connect mode. WLS reachable, the Flex Connect AP and wireless controller, new tunnel. You guys perform all CAPWAP functions. Yeah, you can do that, but this is if you have if you don't have the wireless base. I mean, not the wireless, web base. Now, like I said, most of the access points they use the web base. They control everything to the web. With physical lines. And of course, you have the standalone mode that is unreachable. The Flex Connect AP has lost CAPWAP connectivity with the Flex Connect. It has groups of other business functions such as which runs data traffic, domain like client. So this is the SU. If something happens to the controller, so they need to provide services to the client. So at least the local IP can perform the authentication in case they lost communication with the wireless control. That's a state. Oh my goodness, really? Why is this recording this? How are we doing on time? Doing okay? So, frequency
Yeah, we're
channel
doing fine.
saturation, that's a theory basically. To be honest with you, I mean, when you connect to the access point as a client, you have direct sequence spread spectrum on FHFS or off VM. That depends on the what technology. And I think this is like most of this stuff is old. Okay. So the direct sequence spread spectrum, which is a modulation technique designed to spread the signal over a larger frequency band, used by 802.11b devices to avoid interference from other devices using the same network point. So this basically dictates how the AP functions. Okay. How the spectrum, how they use it, basically, especially when you deal with signals, because the signal is going to get weak and weak and weak in case of how far you will be from the access point. As you can see out of this one here, this is the most usable one, which we call orthogonal frequency division multiplexing, or OFDM, which is a subset of frequency division multiplexing in which a signal channel use multiple subchannels on adjacent frequencies, and is used by the majority, which is 802.11a, G, and AC. So with the new technology, we will focus on AC. So that's what they do. There we go. That's the channels. Because we know we have two frequencies. We have the 5 and we have the 2.4 gigahertz. Now, whenever, and this is your channels. Now, if you notice, now if you're on channel 1, this is channel 1, goes all the way over here, okay? And the channel 1 interfere with what? With channel 2, with channel 3, and channel what? 4. So what you do, that's not good. So whenever you implement, when you implement wireless with 2.2 or 2.5, I'm sorry, 2.4 gigahertz, and that's what you need, 2.4. Okay, you want to separate your channels. So that's why you put a channel 1. Okay, then you use the channel 6 and channel 11. Those are the channels you want to use to prevent interference from neighboring channels. So that's because the gap between each frequency is like 2 points, less than 2 points, which is 22 megahertz. Okay. Now you see that little gap here and here, here. So it's able to have better signal. See that little. So if I'm using an access point, I set it up with channel 1. The next access point, I'm going to set it to channel 6. And the third access point, I'm going to use it for channel 11. Now, the good thing is you don't have to worry about it now. The reason why, because it automatically will adjust. The most access point I've seen now, the new ones, they automatically adjust to eliminate interference. So you have 2.2 gigahertz. This is 22 megahertz gap in between the 5 megahertz. For 5 gigahertz standard 82.11ac, there are 24 channels. Each channel is separated from the next channel by 20 megahertz. When the previous one is separated by 22 megahertz. See? Now, so non-overlapping channels are 36, this. Then you move to 48, which is this. Then the 60, which is this. So if you have a multiple access point and you want to eliminate interference between channels, you want to use the 5 gigahertz, this is what you need to set up. First one 36, and second one 48, and 60, and so on. Usually, a smart software will take care of that. We don't have to deal with it. In the past, we used to tune, like for example, we used to have, we need to adjust the power, adjust the signal, the channel. There was a lot of setup. Plus, you're not having a fast wireless signal. Okay. Now everything's done by itself. So people, what they do now, they have a software. They get the plan, the floor plan of the building. Okay, according to the floor plan, they can determine how many access points they want and the coverage, and based on what types of infrastructure, like what types of walls we have. Do we have concrete wall? Do we have sheetrock? Do we have wood? So according to all this given, they can basically calculate how many access points they need and how to comply. So, and that's what it's saying. The number of users supported by the wireless LAN depends on the following. Graphical layout of the facility. Okay, that's another thing. Now the access point, the more people, that's another thing. That's the access point. Okay, so let's say you're the first one accessing it. So you are the first one access, you get a normal signal. So the next guy comes in, it's going to be lower, lower, lower. So the signal, the more people you have on the access point, because you share it, this is going to get slower and slower and slower and slower. So knowing how many people access it makes a perfect design. And it's not only that, also how you direct your access point. I told you the story like a few summers ago. We have to go to, we went to New Orleans, what do you call it, convention center, and they have like 15,000 people into the convention center. And we helped a big company came from California to set up their access point. So we have to mount all these access points in the convention center. And when you go to convention center, you can see on the ceiling all the rods and stuff. So we have to mount the access point and need to tilt it to a certain angle so people can have better signal. So because they have, like a Cajun dome, for example, you have a different seats, different positions. So we have to tilt to put the access point in certain angles so people, for example, in this section can access it, and how many seats and how many access points we need to put. So we have to do all this calculation. So designing is fun, but it makes it easy if you have the proper tools. What's tools? Well, basically a software. and special software to help you design all that stuff. Okay, questions? No questions? Okay, so it talks about the problem or threats. Yeah. I recommend to watch that video, please. It's a very good video. See how many slides we have. So I'm gonna keep the rest till tomorrow because I'm not gonna cover the whole thing. Okay. Any question for today?
No, sir.
Was okay? Was okay the test? I guess.
Oh yeah, the one earlier. Yeah,
Yeah.
yeah, it was pretty good.
So you were expecting those kind of questions?
Couple of them threw me.
Okay. How about those questions in purpose? Let's get it. All right. If you don't have a question, I will talk tomorrow. We'll finish this chapter and we'll see you in the morning. All right.
All right.
You guys have a good day.
All right. Thank you, sir. You too. Bye bye.